So we've all been there, where product might have come to us and said, hey, we want you to build this thing. They're freaking out a little bit because they think it's going to be really complicated. And it turns out, you've built some tools around that already, and it's not as hard as they think it is. But we've also been on the flip side of that to where they think something is going to be really simple and easy to build, and you might not have great tooling in place, or maybe the tooling you have in place is, let's just say, less than ideal. You've built some weird stuff. So it's more difficult. So this talk is more centered on trying to get us to the point where we're in the former of that group. I am Jake Anderson. I am a senior software engineer at Weedmaps. I'm currently on the live menu team. And so the things that we do are menu management, menu curation, external APIs, and pull-based crawler integrations. But we have a whole bunch of teams at Weedmaps. This is my first time at RubyConf, so super excited to be here. What is Weedmaps? For those who aren't familiar, we are the leading technology company and software infrastructure provider to the cannabis industry. So think all things cannabis, all things Weedmaps. We are actually having a party tonight for the entire conference, so be sure to RSVP to that. It's from 7 to 10 p.m. at the Great Divide. It's at the Bottling Hall off of Brighton Boulevard. There are two Great Divides, so make sure to go to the right one. The Bottling Hall is the correct one. It's going to be open bar, dinner, should be a lot of fun. That QR code should take you to the RSVP, but if you can't scan that, you can go to rubyconf.org on the schedule on the Tuesday page, scroll all the way to the bottom, and you can RSVP there. We are hiring at Weedmaps, so if you're interested, definitely come hit up our booth. There's a code challenge there. If you complete it and pass, you actually move to the final phase of our interviews. So definitely come do that if you're looking for a new job. All right, getting to the talk. So today there's a few things I'm going to try to cover. First of which, what is a DSL, domain-specific language? Sometimes we've heard that acronym DSL, don't even know what it means. So we're going to just level set a little bit there as to what a DSL is. We're actually going to dive right in after that to building our own DSL. It's going to be on top of a rate limiter. We're using this DSL in production, or a version of it in production at Weedmaps, and it's serving us pretty well. At least I like to think so. And then we're going to kind of discuss a little bit about what we did, why we did it, how it kind of worked the way it did, and then applying some of this knowledge towards kind of future projects or any things that you might be doing. So, what is a DSL? What's a domain-specific language? Some of you might recognize this name, Martin Fowler. He defines it as a computer language that's targeted to a particular kind of problem rather than general purpose language that's aimed at a kind of software problem. To me, I didn't necessarily understand this right away, but as soon as I started thinking of it in terms of, hey, libraries are all DSLs. They took Ruby and they had a behavior that they found that they wanted to try to repeat, and so they created a library around it and essentially formed a DSL as to how you can use Ruby to accomplish a certain behavior or task. Sometimes concerns or modules would also be considered DSLs. At the end of the day, it's really any reusable behavior that you might have throughout your code. If you find that you're reusing something more than once, chances are there might be a good opportunity for a DSL there. Not always, but it does kind of hint at doing that. But that's enough about like DSLs at a high level. Let's just kind of dive right on into some of the code, hopefully build out something that makes sense, and then talk about it. All right, so what is a rate limiter? For those who aren't familiar with rate limiters, it's a way to limit a piece of code execution over a period of time. So say you only want something to occur 100 times per minute or 10 times per second. A rate limiter is a way that you can accomplish that. Some examples of rate limiters may be API rate limiters, probably the most common of, hey, Stripe only allows you to hit them every so often, and so you might implement a rate limiter on your side to make sure that you don't go beyond those limits and get 429 errors. But other examples of rate limiters might be login attempts. Maybe you don't want people to brute force log into your application, and you want to rate limit and say, hey, you're only allowed to try to log in 10 times per minute. Other examples might be coupon code redemptions or text messages. Imagine you had a job running in the background and that job happened to run 1,000 times on accident, and you just sent 1,000 text messages to one person, right? It'd be great to have maybe a little bit of a rate limiter in there to be able to say, only send messages to people once per hour, which would prevent something like that from happening. So this is going to be a little bit of a demo of a rate limiter in action. I have a little method called puts dot, and it's going to print a little dot onto a screen. On the left side, it's going to put that dot every half second. And on the right side, it's just going to put as many dots as it possibly can. But they're going to share the same rate limit of 5 dots per second, essentially is the way to think about it. So pay attention to kind of the cadence of the left side, and then see on the right side how when things come in, they really take over. So go ahead and take a look here, 2 separate terminals. So here on the left side, we got those dots kind of printing to a screen every half second. And then the right side kicks off and starts going, but you'll notice it does pause, right? Because it's hitting that limit, it knows it needs to stop. I made the 5 requests. The one on the right finishes, and then the one on the left finishes. I'm going to run this one more time, and pay attention to the left side. You'll notice that it's very sequential. It's going at a very steady pace, and then as soon as the right side starts, it really slows down, and that right side really starts to eat everything up. So we'll go ahead and watch this again. You can see that left side really starting to slow down, and then the right side will finish up here, and it goes right back into its regular cadence. So we'll talk a little bit more about that. Just wanted to call it out. Don't want to run this again. Cool. Perfect. So the rate limiter class. I don't want to dive specifically into rate limiters. I will provide a gist at the very end if you want to see how the rate limiter itself is implemented. The focus here is building a DSL on top of the rate limiter. And we'll talk a little bit about why we're doing that. So all we need to know about this rate limiter class is it accepts the first argument is a bucket name, and that's just the key that we're looking this rate limit count up in. To be like, oh, hey, this has happened 1 time or 10 times or 42 times. It's all going to be in that bucket namespace. It also has some other arguments. This particular rate limiter is backed by Redis, which allows us to have both of those processes running, as we saw in the previous slide, still respecting that same rate limit. The second thing to call out here is this within limit method that accepts a block. And anything that within limit just kind of wraps whatever block you pass to it within the rate limited functionality. Again, just commented that out just to focus more on the DSL layer. But the within limit, if you are within that limit, that block will run immediately. Otherwise, if you are not within that limit, it'll enqueue a sleep. It'll just wait a little bit longer, and then it will try again. So it'll more or less put it on hold, and then once that rate limit becomes available again, it will retry, as we saw in the demo. So one way we can use this is like this. We have a rate limiter class here at the bottom that we've memoized, so we don't have to instantiate a new one every time. And in each one of our methods, thing 1, thing 2, we call our rate limiter, do the within limit, and kind of do our thing. And what's nice about this, it doesn't matter if you're calling thing 1, you're calling thing 2, you're always going to be respecting the same API limits across your entire application. But as we saw in the demo, that the right side that had the no limits in terms of how much it was executing was taking up a lot of that bandwidth. And, but it still worked. But is there a way that we can prevent one particular class from just taking over the entire rate limit? And if we're only allowed to do 100 per minute, and one class is taking up everything, well then nothing else can get everything done, which is less than ideal. So can we build a way to kind of handle that scenario? And so right here, we're starting to introduce a behavior around rate limiting, and we're going to call this local versus local, or global versus local rate limits. And it might look something like this. We have thing 1, and we've got a rate limiter local and a rate limiter global, and then we're doing some nesting to we're like, hey, we're gonna first try to get the local rate limit, and then if we have that, we're gonna try to get the global rate limit, and then we'll execute our block. But don't feel great about this, right? It leaves some weird nesting, and to me, I don't like this. It seems like kind of some gross Ruby code. Like coming in this class, I'd be like, I don't really want to touch thing 1 or thing 2. Some of you might have caught it, but thing 2 actually grabs the global lock before it grabs the local lock. And that might be a problem if you have something continually grabbing in that local or the global and then not actually being able to do the local because it's using your global rate limit, but not actually executing anything. So nothing else can do anything, and neither is your class. So it seems like it's easy to kind of misuse this global versus local limit. There's also a bit of setup, right? You kind of have to set up this global limiter and set up this local limiter and then do the nesting. And so we're kind of seeing a pattern here or behavior that maybe would be good to wrap in a DSL. But what might that DSL look like? And a great place to start when you're thinking about writing more of that developer-centric DSL is how do we want to use it? And then we'll focus on how do we want to implement it. So focusing on the developer journey and then figuring out the implementation. I also try to recommend not going with the first pattern you think of. It might be the best one, but it might also not be the best one. If you have other people on your team, definitely reach out, get their opinions and thoughts. And so we're actually going to show 2 different options, and we're going to implement both of those options just so you can kind of see different worlds. So one option would be to do something like this. To introduce a method within a class called withinRateLimit, you can pass that a block, and then it will automatically take care of the global and local rate limits for you. This is great in the scenario to where you always need this function to be rate limited. Say you're using an external API and you need to always guarantee you're hitting it at a certain interval. This is a way that you can guarantee that, and no one else in the code base can call this method without being subject to that limit. However, what if you don't want that case? What if you have thing 2 and sometimes you want to call it rate limited, but sometimes you don't? So in this case, we can do a little bit of metaprogramming to introduce this concept of a rate limited method prefix to where if somebody calls rate limited thing 2 or rate limited thing 1, it will automatically know to wrap that in our rate limiter and execute that function. But you might have noticed there was nothing around configuring these rate limits, right? Like, how are these things supposed to know I need to execute 1 per second or 1 per minute? And there's a ton of different ways to do this, but one way that we're going to do this in this example is through a module and class level configurations. If you're familiar with Rails, you might have done this with devise, to where you hop in the Ruby class, the user class, and you write devise, authenticatable, all those types of things. We're going to mimic that same type of functionality to where you can define class level configuration, and in this case we're calling it a rate limiter. You can pass it a bucket name, so in this case I'm calling it my service, and then you can have global and local rate limits that respect that. So like in this case here, we've got a global rate limit of 100 per minute, but we're only allowing each individual service to call it once per minute. So yep, we define our global local limits. Our method will refer to these limits that within rate limit that we were showing in the previous slide. We'll look up these on the class. And then what's nice here is these definitions are at the top of the class. So when you hop into any Ruby class, you can very quickly see, oh, hey, rate limiting is in here. And I can go ahead and utilize that in whatever way that we've defined to do that. But let's get coding. So we're going to start with the module and kind of like this base configuration. And some people might come from the Rails world. You've got active support concern. You can do included do blocks. We're kind of skipping that a little bit and keeping things pure Ruby. And you can accomplish it by doing something like this. Classes have an included method on their main class, and you get the class that's getting inherited, and you can extend that out. So that's essentially what we're doing here is we have the class methods, and everything that's in that class methods module, we want to add as a class method to whatever this module is included into. So that's our rate limiter function right there. If we go to on the previous slide, we got that rate limiter definition there at the top, so that's where that's coming from, is in that rate limiter method definition. And we're also setting a memoized value of rate limits that will be able to be referenced through any instance of this class. So yep, create the methods, extend the class, and note this doesn't actually do anything yet. So this works. Like if we did everything in our code before, it's not going to break, and you could ship this to prod, but nothing is going to be rate limited. It is literally just going to keep passing things right through that within block and really do nothing for you, which is obviously less than ideal. No point of having a DSL that does nothing for you. So let's go ahead and add some functionality to that method. And it would look something kind of like this, right? To where we have this, we're going to try to grab that local limit. Now we're going to try to grab that global limit. We're going to pass that block all the way through. And some of these methods here at the bottom are more or less just helper methods to generate all that stuff out. But some of you may have noticed it's more or less mimicking the same functionality we showed previously, right? To where we have that rate limiter local within limit, rate limiter global within limit, and then we have that block right there in the middle. But we've abstracted that away, so now no one needs to know, like, oh, am I supposed to do the global first? Am I supposed to do the local first? Like, don't even worry about it anymore. We took care of that. Just call within rate limit, and you're going to be good to go. Again, all of this will be available in GIS afterwards, so don't feel like you need to take a whole bunch of shots. But we talked about metaprogramming, right? What about that option 2, where we want to have that rate limited prefix? Like sometimes like that seems kind of cool, like metaprogramming in Ruby, like that sounds kind of fun. Let's how might we do something like that? For those of you who aren't familiar, Ruby has a method called method missing. And if you try to call a method called thing3, we never had a thing3, if we try to call that, what's going to happen is method missing is going to get called, and it's going to pass that method name and any arguments that you pass to that non-existent method. And you can then define those methods or pass through those methods on the fly, hence the whole metaprogramming. And so really what we're doing here is we're checking to see, hey, the method that got called, does it have this rate limited prefix on it? If it does, we care about it and we're going to do some stuff. Otherwise it doesn't, we're going to call super, pass it back up the chain, and some other method missing can get to it. But in this case, if we had rate limited thing2, we know, oh, this is something we want and that we care about, so we're going to pay attention to it. We're then going to wrap what we got within that within rate limit block, and then call that method without the arg, or it should say with the args, or without the prefix passing the args. Okay, no, I wrote it right. So it looks something like this. That within rate limit we defined in that previous slide, we can just reuse that method right here. It might be hard to see the little yellow brackets, but that within rate limit is getting a little block there. And what that block would look like is something like this. We can do a public send to whatever the method would be without that prefix. And so again, if we got rate limited thing2, what we're doing here is we're moving rate limited underscore from that method name and just calling thing2. We're then passing through any arguments that we got to that. For those of you who aren't familiar with that ... syntax, JavaScript has something very similar. It allows you to essentially say everything else that you get here, just like pass it on through as these dots, and so you can kind of go through the dots that are above and below. The method signature, however, are more just to show that there's other things happening in the file, not to kind of confuse that. One other thing to call out here is we're using public send. It's best practice with metaprogramming generally to only call public methods. If we had this as a regular send, we could access, or anyone can access, a lot of our private methods, which is less than ideal. So by using the public send, we can guarantee that we're only using the public surface area of whatever this module is getting included into. Lastly, it's generally not a good idea to add multiple ways to do the same thing. right? We implemented this meta programming way, which is great, it's fun, it's a good use case, but then we also had this other way. If you have two ways to do something, people are going to use two different ways to do it, right? And then you have two different usages within your app, and you've got one team that uses it this way, one team that uses it that way, and so when you want to introduce a change, you now have to support both use cases. So it's typically best to stick with one. We did both just to kind of show the different examples of how you could implement a DSL like this. But can we take this one step further? What happens if we have a service that doesn't want a local limit? We only care about a global one. Like, you know what, this one can eat up all the bandwidth it wants, I don't care. Or maybe it's the opposite. Maybe I only want to run this one locally. Or what if I forgot to add in those rate limit definitions? Like, it'd really stink if all of a sudden the app went down, right? So it'd be kind of cool to introduce a concept to where if we don't get a bucket name or if we don't get a rate, we just pass everything on through and just call it as if there's no rate limits there at all. So like, how can we do that? How can we execute that block? So if we go and revisit this rate limiter class, and I know there's a lot that's abstracted away here, we can look at this within limit call. And right now it's getting past that block, but what we could do is something like this, to where we can immediately call that block if it's unlimited. Ignore the rate limiter altogether. I don't want to touch Redis, I don't want to do any of that. Immediately call that block. But what does unlimited mean? And we can call unlimited to just like, hey, if you didn't give us a bucket name, or if the rate that we got was 0, it's considered unlimited. Just like pass everything right on through, rate limiter doesn't exist. We can also use the .0 here, because if you're not familiar, in Ruby, if you call nil.2i, which is kind of what we could be doing in this rate at the top, you get 0. So yeah, now we have a conditional rate limiter that's officially supported. So if somebody included that module for a rate limiter and didn't add a global or local, it's like nothing ever happened. If they add the global, we're going to respect the global. If they add the local, we'll respect that. But if they add both, we're going to respect all the things. So here's the end result. As promised, this is a QR code to the gist where you can see this rate limitable module. You can also see the rate limiter itself. It's just GitHub gists and commits happen on GitHub. It's also on my badge, which I am not wearing. But you can always find me after the talk if you want to learn more and you can't find it. So that's great and all. We built this DSL, but like, what did we learn by doing this? Like, what was the value, and how is this even developer-centric? And really, it comes down to 5 principles or rules. Like, I hate the concept of rules or principles because it means that something always has to be done a certain way, and I don't think that's true. These are just some of the principles that I like to follow when building DSLs, and we find at Weedmaps tend to be more developer-friendly. First things first is, do we even need it? Don't build a DSL unless you need a DSL. Rule number 1, right? Yes, it's cool, it's fun. Building things in Ruby is always fun and interesting, but if you don't need it, don't build it. In our example, we kind of saw at the beginning, we had that weird nesting, and then you can kind of put those in different orders, and so it kind of made sense for us to build a DSL more from the reliability standpoint and reusability. We don't want people to misuse our rate limiter. And so we've kind of found a good need to create that. Second rule, begin by thinking of the developer usage first and then think about the functionality. So what we did, right, is we're like, okay, how do we want to use this? And we had that within rate limit method, we had that meta program method, and I'm sure there's a whole bunch of ones that I'm not thinking about that aren't on this slide. If you've got ideas, definitely come hit us up too. We'd love to hear them. But we focused on the developer usage first, and then we figured out how to make that happen. Typically, that's the best way to do things if you can. Start with the developer. You also notice that, as I kind of mentioned here, rule number 3, explore multiple patterns. The first one might be the best one, it might be the worst one. I didn't come up with the meta-programming example until I was doing this talk. And maybe that would have been a better way to do this rate limiter overall. So by taking the time to explore more patterns, you explore more possibilities, get more people involved, get the whole team chatting about it. But at the end of the day, favor consistency. Don't have more than one way to do the same thing. Try to be consistent with your DSL. It's great when you know a DSL enough and can pop into any class and, oh, I see it's got that rate limitable module in it. I know exactly what I need to do to rate limit stuff. Rule number 4, keep it focused. The rate limiter, we could have introduced functionality that's maybe specific to API clients like HTTP, or we could have made it specific to text messages, but we kept it super generic. You could use what we just did for APIs. You can use it for text messages. You can use it for any of the examples that I gave earlier. So we kept it really focused on a small piece of behavior and didn't really extend it any more than we needed to. And so if you find that you're like, oh, maybe there's something that it would be cool to implement this thing now, just wait. Just don't do it. Just give it some time. It's always easier to add functionality later than to try to rip functionality out that you realize that you don't actually want to use. And the last and final rule, arguably one of the most important rules, is try making error tracking as easy as the implementation. I think one of the reasons people don't like DSLs is because of the meta programming and some of the magic that happens behind them, to where when you got Honey Badger raising an error and you're like, oh my gosh, I have no idea where this is coming from. It says thing 3 is not defined, but like I'm not calling thing 3 anywhere in my app, and so how do you make some of that a little bit more user-friendly when things inevitably do go wrong is super important. So make sure to think of that journey as you're building some of these DSLs. In our method missing, for example, we could have raised a custom error there that the method wasn't defined, pointing more towards our rate-limited DSL so that somebody knew that to look up rate-limited thing 3 and not just thing 3. So parting thoughts, like where do we go from here? I've got some examples of things that you can do to just take this down and add some functionality to it, right? Hopefully you learned enough to kind of think of what might make good DSLs, how might I build that in a developer-centric way, but if you want to just start with this rate limiter and potentially build out some more functionality on top of that and kind of wet the palette a little bit, here's some ideas on things you can do. One idea is to move the configuration to something global. Maybe you're creating a gem that needs to use rate limits, and you want people to include your gem but be able to configure those rate limits. So moving that type of configuration to global might be something that you can do rather than doing it on the class itself. Another option might be to minimize the amount of methods that you have defined, even more to prevent method bloat. So every single method that we add to our module gets included in the class that's included in. So the more methods we have, the more we're bloating up that space and have a potential to collide with anyone else that's writing methods within that class. And so it's typically also a good idea to keep your method names very small and concise and specific to what your particular DSL is doing. But more on like the rate limiter configuration side of things is maximum retries. So in our rate limiter, we are using Ruby's native timeout functionality to where if things don't complete within 5 minutes, just like kill it. Raise an error, like make sure it's done and go away. We don't want something just getting stuck in an infinite loop. But maybe you want to add functionality to where like, hey, like I want you to loop as many times as you need, but don't go more than 100. Like if you've done this 100 times, just like move on, error out, like re-enqueue this to try again in an hour or something like that. That's a great thing to try to add in. Another configuration option might be delays. So the rate limiter example that you'll see in the gist, when it enqueues and it really just sleeps for a second and then it tries again. And so maybe you want to sleep for 5 seconds or a minute, and you can make that a configuration option to customize the amount of delay or sleep between those retries. The last one I'm not crazy about, but you could do it if you really wanted to, is allowing for people to override those class level definitions on those rate limits. So when you're doing something like with rate limiter, being able to say like, actually for this method, I want the rate limit to be this and not respect the global limits, you can do that. So that's another way that you can extend this DSL out. But at the end of the day, build for what you need now, not what you think you'll need later down the road. It's much easier, like I said, to extend functionality than rip things out that you no longer want or need. Thank you very much, and if we have time for questions, I'll happily take them. If not, I will be at the Weedmaps booth, so come hit me up. Thank you very much. Yeah, so let me see if I understand the question. So like, what are we doing to ensure that we're actually respecting our rate limits? Yeah, so we've got partners that are pretty loud, so they'll usually tell us if we're not respecting those limits. We'll also start seeing those 429 errors come through. And so we've got some monitoring in place that tells us, and we can monitor and say, oh, hey, we're seeing an increase in 429s. That's actually how we, the whole local and global thing, we originally had that flipped. And we figured that out pretty quickly that was the wrong way to do it. And so we flipped those around and realized, yeah, that was probably not the smartest. But because we had that monitoring in place, we saw the 429s, people were reaching out to us like, hey, you're not really respecting these limits. So we made that fix and were able to kind of prove that it was working accordingly. But it can get really tricky to test some of these things when you're working with, Redis and things across processes for sure. Ooh, that's I mean, I'm more thinking of this on the fly. I'm not saying this is a good answer, but there's always arrays, right? You can have your API config can be based off of arrays, and you can just kind of go through that list, starting with the first, and if that one fails, implementing retry logic to try the next one in that list. Just one way that you can kind of implement that DSL and potentially within the configuration, right, you can say the index at which you prefer that API key to be used. But yeah, that's definitely a tricky topic for sure. All right, well, thank you very much. If you have anything else, come find me.